hard work. Yeah.
Great.
My name is Heather Banda. I'm a PhD student at the University of Pretoria.
I'm Cerene Rathilal, and I'm based at the University of KwaZulu-Natal, where I have been appointed as a senior lecturer.
Lovely. So we've got an very nicely representative spread of experience at the sort of early to mid-career level of a researcher here, and I think our conversation is really going to be interesting because of that. So guys, I'm going to start us off with the first question, which all of you are going to reflect on quickly. So we're going to talk around your positioning or your understanding of your position when it comes to potential for impact. So your science is great and it's getting better, but how much more can you do with it for you to actually say you're reaching impact? Okay, so question is going to be something like, can you share any achievements or highlights that the current funding that you've received or previous funding you received in this ecosystem has enabled? So any highlights, anything that you can share around some of the achievements that this funding has enabled in your own career development? Can I start with you, Walt?
Well, I was very fortunate to go on an exchange to Leiden University in the Netherlands for 5 months during 2021 and 2022 to collaborate with my co-supervisor from Leiden University. So that was a very enriching experience, seeing a different university, a world-class European university, and seeing how it's also interesting to compare actually how favorably in many different ways, specifically Pretoria, is compared to a university that's, as far as I know, ranked in the top 100 on most of these lists that we all know. So that was very rewarding. Also, the CoE has been involved with yearly events where we take part in learning how to do effective public speaking, science communication, and these have been helped me, I suppose, to receive some prizes for student talks at various SAMS conferences, 3 SAMS conferences, so that was also nice to be a part of, so yes.
Awesome. Okay.
I would say that, yearly meeting with CoE that has helped a lot with science communication. And thanks to CoE, it is always difficult because sometimes you cannot express some of this into the real world, but yeah, it really helps, yeah.
Yeah, I know your research area, and we had a chat this morning about how difficult it is to just explain it even within the field, so I appreciate how it can be challenging.
Yes, it is.
So I still remember when we were doing the lessons of how to communicate with people, we were actually asked to explain your research in a way that your grandmother would understand. So actually, it's important to communicate your research to different people so that they understand where you're coming from. So due to that, despite the level of the people, whether they are doing something which is not in your field, you can actually try to translate what you have learned in a way that they understand.
Appreciate it.
So I echo everything they've said, but I'll add that it was that sort of interaction that sparked many ideas for me that slowly started to emerge soon after, which led to some projects that now exist today. For example, some of the math outreach that we do. One of the programs that I'll mention is the Future Mathematicians program, which came into fruition last year. And that in its form, in its true essence, is a form of science communication because it's about taking mathematics to the larger community. And so the Future Mathematicians program was officially made a division of the South African Mathematical Society last year. And so this year there are lots of big things to come, and of course we're looking for people to network with, people who would like to contribute to rolling it out to South Africa. Yeah.
Sure, great. Okay, so let's move a little bit into you as a scientist. So let's look at beyond your publications. How do you envision that your research can be impactful in the field of maths and stats in the long term? So if you think about in the next 5 years and what you're doing right now, how do you see your research being impactful in the fields that you're in?
Well, this is the
This is the most difficult one, yes.
okay. Yeah, so my research started off in a general functional and analytic setting, specifically in looking at field of vector lattices, respaces. So, but what's interesting that what happened over the period of the PhD was that we sort of stumbled into having to use category theory. So, and there isn't much of a presence in terms of category theory at University of Pretoria, but now there are of course lots of people at Stellenbosch that use category theory. So, in terms of, and it seems to have this sort of coming together of these sorts of ideas in functional analysis and the applications of category theory at the end of the day is interesting to see, and this seems to be taking off at the moment. I can get into specifics, but perhaps.
Tsinjo?
I think because I'm doing model theory, it's pure mathematics, and not sure how, but because at this point I don't have any even application to mathematics, so it is just going to develop further theoretics.
Yeah.
Yeah.
Yeah. Makes sense.
My research is in cell biology, so mainly I analyze normal cells and cancerous cells using mathematical modeling. So I'll be actually looking at the difference between the normal cells and the cancerous cells in order to see how normal cells transform to cancerous cells. So from the results that I get from the simulations, we are actually talking to biologists to come up with ways of how to look for treatment for cancer. So maybe in the long run, we'll just keep on looking for more models and try to match the results from the models to the data that comes from the experiments. So I think maybe in the long run, we'll be able to actually try to clean our results, and it will help to find the treatment for cancer.
Amazing.
So my work is also quite theoretical, and I work in point-free topology. But what I did do before in my master's was I studied a bit of hyperspace theory. And so what I'm trying to work on towards now is trying to generalize that theory into point-free topology, into understanding what a hyperlocale might look like and what would metric structures on it also translate to. So hopefully that would open up new possible research streams that one could consider, because it has not been done before. In addition to this, I am part of a research group at NITEX. And this is led by Professor Zura Byanalitsa. And one of the things that we encourage there is sort of multidisciplinary research. It's about trying to find connections in everyday things and how you could use your mathematics to describe phenomena. And so that's something that I'm slowly gravitating towards as well. So more recently, I started learning more about topological data analysis, through which theory, homology theory, and work that's done in algebraic topology, that's theoretical, is utilized in an applied way.
Sure. So that is amazing, because to a certain extent, as you develop as an early to mid-career and sort of getting more sophisticated in your research, it helps if there's a support system that helps you understand the value and relevance of your work for the future that you are heading into, in the discipline, in academia, in the application of those ideas, etc. And so mentorship becomes a big part of that. Okay, so let's just segue quickly into looking at mentors. Can you identify, you don't have to name names, of mentors, people that perhaps a role that was in the university system you're in, a person that really influenced you or supported you in a positive way towards understanding what career path you can be taking? Walt?
Is it working? Yes. Okay. So, yeah, I must say our department at the University of Pretoria is in a very positive position. We've built up a quite substantial group working in functional analysis, and we're all supportive of each other at the end of the day. So we treat our research as partly as we just meet for lunch and we just discuss things at the end of the day. And in that way, if we have ideas that we want to share, or so specifically for me, being a younger member of the group, everybody in that group ends up being a mentor for me.
Yeah, yeah.
So, yeah.
Tsinjo?
Yes, so I was in Stellenbosch, and the only one who is doing my field on that time was
Yes.
my host, my supervisor.
Yeah.
And of course, he's a mentor and supervisor, and yeah, the whole department also helps.
Mm.
Yeah.
I did my undergrad and master's in Zim, and in the mathematics department, there were just few women who were doing mathematics. So there was just only one female lecturer, and she was a doctor. So that just motivated me to say, one day I just want to be a doctor.
And now you're a doctor of a different type?
Yeah.
So for me, mentorship has played a huge role in my life. My first mentors were my supervisors, and that is Professor Dharmanand Babulal and Professor Paranjoti Pillay. For me, it was also important to have Prof. Pillay because she was a female mathematician that I could look up to. And then beyond completing my PhD, I was lucky enough to join a program that Professor Loyiso Nongca had created through the NGA-MaSS. And this was the PSACP program. It's a pathways program for early career academics. And through that, I was able to be mentored and learn the necessary skills to navigate academia, which at first seems like a very scary place to be. Yeah.
In another capacity at Wits, I'm program managing the Carnegie Diversifying the Academy program. I can 100% attest to the need for a program that helps you navigate academia. It's absolutely critical, and sometimes we don't think about our institutions as disablers to the development of a career academic, because the experiences that you could have, especially at early career level, could really taint the picture that you've got of academia or completely boost it in the positive direction. So those programs, when it's a program, it's really, really beneficial. So thank you for those reflections. Can we have the Mentimeter running on the first question in the meantime? You can just put it up, but we're going to carry on having our conversation. The Mentimeter could be running and the audience giving their reflections. So I want to now speak to the two ladies in the panel, because these questions are going to have, I think, some kind of reflection that is for you guys to really think through. So academia can have its own challenges related to gender, related to race. Can you share some experiences you've had in this regard and how you navigated it?
So women are a minority in the mathematical sciences, and there's a lot being done to address that. So my experience, and I chatted about this yesterday, we had a Women in Mathematics session that was hosted by Professor Karen Therese Howell. And I mentioned during that session that my experience was being the only female student in the honors mathematics class, and then that translating as I also moved higher in the postgraduate studies. So of course, that could be very isolating. But lucky for me, as I mentioned, I had my female supervisor who was my role model, and that kept me steered on the path. But more so, I think I was very passionate about the work that I was doing. And so that also kept me fully driven. But that experience has led to me wanting to address these issues and to give back to the community and to make sure that other girls don't have to experience what I might have and not have to experience any feelings of isolation. And so that's led to some other engagements that I had started, and one of them being a STEM mentor, where we give back and we support young girls who want to pursue careers in mathematics and science.
Lovely.
Actually, as a mother, you have to try to balance your schoolwork and being a mother and also maybe being a wife. So you have to actually come up with a way of balancing the school and that. If you're not able to balance that, you might find that it might end up straining your academic work, and at times you might actually drop out of school.
True. Tsinjo, as somebody coming from Madagascar
Yes.
into the South African science and innovation system and the university system, can you reflect on any challenges that you may have had, perhaps?
First of all, the system is different. Madagascar is using French system, and back there we had a very pure theory mathematics. So you don't know how to is it useful? But you just get an equation, you solve it. You got a differential equation, you solve it. But when I did AMS, I see application of what we did, and then it opens door. And South Africa, as I did my master in Stellenbosch as well. But I stick to the pure mathematic parts that I have been used to. Yeah. So.
I had an interesting chat with you earlier on, and you were reminding me that you had to translate theoretical maths from French to English.
Yeah, that was a big
amazing.
challenge.
Yeah.
Yes.
Sure.
And
That's
I think until now, we still have this, but it's now in
Getting better at
lesser,
it. Got you. Sure. So, for everyone, building a strong research network is obviously very important for your success. I think we've had it being reflected. Now, talk to us about your involvement in this particular network and how that has helped you develop research partnerships or get better collaborators or opportunities for collaboration. So here we're talking about this particular network within the CoE-MaSS, within AIMS, etc.
In terms of how it's helped us.
Yes.
Well, I mean, in terms of the Fouts session that happened over Sunday until yesterday, I mean, this would have been much more difficult to organize funding-wise, having students come here, all of this, if it wasn't for the CoE-MaSS's contribution to that. So certainly the CoE-MaSS has been extremely involved with just particularly functional analysis conferences over the last few years, which has been very helpful. Sure. And also in terms of giving students access to funding to travel to conferences. Yeah. So it's been very helpful.
That's good. Tsinjo, you came into the continent, well, you're from, but you came into this side of the continent through the AIMS network.
Yes, I went.
So talk to us about that,
So in 2013, I went to AIMS Ghana. So where I did a project with Prof. Patrick Doré here in differential equation, and then to finally do my essay on the algebraic geometry. Then after AIMS, I switched to a different topic, which is model theory, where I only found it in Stellenbosch at that time, and and now I'm still doing it, and I love doing it.
Yeah.
Yeah.
Actually, besides the funding, when we do trainings like the annual general meeting, we're taught how to communicate with people. So those are other trainings which are not related to academia, but they help in a certain way to groom you as a future researcher. Thank you.
Sure.
I'll touch on what Heather says, because that's where the first collaboration network emerges
Yeah.
from the annual research meeting as a postgraduate student. That's where you get to meet fellow students and researchers. And then for me, my next step into the CoE-MaSS network was when I joined as a junior focus area coordinator for algebra and topology. I think now it's called AFAC instead of JFAC. It's Assistant Focus Area Coordinator. And this opportunity came about because, well, it was through Prof. Bernardo Rodriguez. So he had requested a few applications and he made a decision. And so through that, I got involved with being able to network and meet other researchers in algebra and topology through the CoE-MaSS network. And also feeling responsible enough to lead some of those interactions, because now you're in a position where you should be accountable for what you're doing. So yeah, for me, so that was the birth of collaborations, networks, meeting new people. And I think other ways that students could benefit is through conference attendance, which the CoE-MaSS does support via ad hoc grants, etc.
Yeah. It's been mentioned, I think, in this set of questions, but even before, this idea that the funding enables you to travel, okay, and you travel to conferences. And this is, it hasn't just been that way. You know, there was a time when it was, and probably still is, a bit more difficult to justify why you need to travel to X amount of conferences, etc. But you are underscoring it as something that is enabling better collaboration, exposure, building confidence, etc., etc. Are there any other types of experiences or support that needs to be funded that you think could just make you a better researcher that perhaps are not being funded at the moment?
Well, perhaps my own ignorance is the issue, but on the eve of the breakout of COVID, we had this simple conference it was at Wits in 2020. This was in January of 2020, where the whole idea is just that a bunch of established researchers would come to a particular place and they would give a series of lectures, graduate level lectures on a particular topic. So it's like a little bit more, so we, in the functional analysis conference, operator theory conference that just concluded yesterday, we had a mini course on JB algebras, 4 lectures, but these lectures were a little bit, there was more lectures there, so this is, in terms of actually getting more exposure in terms of doing research, these sorts of more extended courses are often very useful, because then it can expose you to a topic in depth. You're there for a week or two, and that's all you're doing. So if this sort of thing, perhaps there is an initiative like this that I'm not aware of, or maybe I haven't heard of SIMPA since 2020. At least we haven't had one in South Africa, as far as I'm aware.
There has been.
There has been.
Yeah.
Well, not in functional analysis, at least. So, yeah.
Sure. So those courses very, very critical.
Yes.
Thanks, Walt. Now, you've gone through the experiences. You know what it's like receiving the support, not receiving support. You know what it's like having a supportive environment or a disabling environment. What advice would you give to an aspiring postgraduate or postdoctoral fellow in how to network better, how to leverage support environments to network and build collaborations, or in general on how to move as seamlessly as possible through early career and to mid-career levels in academia? So what would be your advice?
Perhaps Cerene can answer first.
Okay.
Since she's the most senior amongst the 3 or 4 of us.
There's a number of things that I could add. Number one is the mentorship aspect. It's good to identify people in your research domain with whom you could communicate and with whom you could seek advice from. I think it's important to know key people. For example, if students have not yet heard about the NGA-MaSS and what they are doing, then they should reach out to Prof. Loiso or make some attempts to join the network, because that is an invaluable resource that Prof. Loiso has made available to all early career mathematicians and statisticians. something that I could spend a lot of time talking about because it's done me such a great deal of good in my growth as a researcher. I'd also like to add that when you identify that you have experienced some problems or challenges, don't keep them to yourself, because doing that is not going to help improve the situation. That was something that I learned. You would be surprised, or maybe it's not surprising at all, that all your senior colleagues and researchers, all of the seniors in the department, are very much there willing to help you as a young mathematician and a young statistician grow. And so at first I struggled as an early career mathematician with supervision because I was not able to attract students to supervise. I struggled for a while, for about a year, because why? I kept it to myself. And so by reaching out, by letting your HOD know, your supervisors, if you've completed your PhD, your ex-supervisors know, by speaking to Prof. Luiso and others, you could receive the relevant advice that could help you surpass those challenges.
Thank you very much. So we've got some responses. Great. I like the participation to one of the questions that we had up on the Mentimeter. The future of maths and stats is bright. What are the sort of areas that you think we should be focusing on? Yeah, I mean, what do you guys, I mean, can you guys see the stuff? What do you think of what the audience is saying? JV algebras, there's the one on modeling how a healthy cells evolves into cancerous cells. Well, they like that, Heather. Apparently it's a research area that should be focused on. Category theory, it unifies some of the fundamental aspects of diverse scientific disciplines within and beyond mathematics. So we are seeing leaning towards much more transdisciplinarity. So there is a lot of really sort of great ideas and suggestions, but the real sort of understanding and appreciation that there are areas in which we should see the sciences grow into. And that's really, really, really great to reflect on. So thank you, audience, for that. So now I'm going to come to the last set of questions that we're going to reflect on. And these ones are easy, very, very easy. They're about the future. And we all know that the future is very easy to go into, right? Nothing to be scared of there. On the Mentimeter, as we're having this discussion, can we have the question up that asks, can you share suggestions for fostering more inclusive environments in these particular fields? So if you could have that question up and have the audience reflect on that. So I would like you guys to just share, within maths and statistical sciences, what are the kind of exciting new areas that you are seeing emerging that hold some great promise for future discoveries?
Should I start? Okay. Well, yeah, maybe I can give a better answer at the 30-year celebration of AIMS. So at the moment, within the functional analysis community, well, there's vector lattice theory has been a big part, is emerging and is becoming stronger in this community, and we also have a strong group that is starting up in, well, they've been doing research for a long time, but it's also expanding at this stage as well on, I'm not entirely sure what term they prefer. Professor Watson this is Professor Watson's group, the measure three stochastic processes and probability theory. This is something that I've recently only been exposed to, but this is very interesting, and we have a strong collaboration between a group of South African mathematicians and Tunisian mathematicians that are also involved in this, as well as some people from Europe. So this is exciting. And it also, well, I mean, I don't need to reach to say that this is really actually making a connection with applicable industry in terms of financial mathematics and all of this.
Yes.
So, yeah, this is certainly something that is exciting, that we can
look into the bright future.
Yes.
Thank you so much, Walt. Cerene, do you have any thoughts?
I don't think I can comment fully within mathematical sciences broadly, but I can comment
in your area.
Yeah, for myself. So we also had our topology for tomorrow session, and we ended that session with a panel discussion yesterday. And through that panel discussion, it was also touching on these things. What happens in the future? It's about topology for tomorrow.
Yeah.
And one of the emerging things was about topological data analysis in South Africa, because we don't have the expertise here. And how do we now start generating the capacity for that? And so I think one of the ways forward in my area, in topology in general, is being able to bring researchers to South Africa.
Yeah.
So we could host these sorts of discussions and mini schools, etc., to spread the knowledge, to diversify, but also just to comment in general. I think when it comes to mathematical research, it's our imagination is the limit. I mean, right? So you think of an idea, you can pursue it, and you use your intuition to guide you on what it is that interests you.
That's good. So for Heather and Tsinjo, we've had some insights around what the future, bright future could look like. But now we have to sort of bring up another generation into that bright future. Get them interested in maths and statistical sciences, maybe even from high school level. So can you sort of give us your ideas and thoughts? How can we improve the way undergrad and even high school level maths and stats or mathematics really courses are taught? And to get them much more engaging and to get young people really wanting to participate in becoming the mathematicians and statisticians of the future?
I think that there is need to come up with programs whereby people move around in high schools and try to give career guidance to the students, because most people, especially for mathematics, if you tell them that mathematics, they think that maybe it's hard, but I don't think it's that hard. So it's just an issue of trying to give career guidance to the students in high schools. And when they come to actually tertiary education, they'll be knowing which programs to actually apply, because some of the programs they won't be knowing them. They know being a doctor, engineering, or those popular programs. So yes.
Sure.
Okay, so we can take, for example, of Olympiad mathematics at the high school level. So we could make use of those and maybe we should improve if it can be done.
Yeah.
And with guidance, as Yever said, it would be helpful.
Yeah. Heather, you want to add?
And also these days, social media can be used to reach out to many people. So maybe you can use LinkedIn or even Facebook to actually try to reach out to many students to update them on the programs that they can do in tertiary, which involve mathematics, statistics, and the other fields, yes.
Yeah, so the visibility is a key part of it, so creating more visibility. But there's the other side of it, which is, I would say, creating a lot more intimacy between the student and the one who is a mentor. And maybe you can reflect a little bit about that, Cerene, because you've been working in mentorship and coaching to a certain extent. And in particular, thinking around the role of the teacher. The first person who really introduces you to it and tries to encourage you to do it. What is the mentorship looking like? Is it effective? Are young people interested through these mentors that they actually have in the form of a teacher?
Well, talking about my experience through STEM Mentor and also my experience in being mentored by others, I felt that it was truly effective. Because you get to have a one-on-one private discussion with someone where you could share your private thoughts, where there's no fear of embarrassment, because you would have had the opportunity to forge a deeper connection with them, someone who understands what you are going through because they've already gone through it themselves. So that is a rare and a very valuable resource to have, being able to work with someone who could mentor you and provide you with guidance on how you could grow and reach your maximum capacity. With STEM Mentor in particular, we identified students who wanted to pursue careers in mathematics and science. And then, based on their interests, we would pair them with an academic mentor from university.
Okay.
And beyond just having one-on-one discussions, the mentorship is structured in various other ways, including group discussions, where the students themselves get to share their experience and learn from each other. There's also the aspect of shadowing, being able to see what the person does throughout the day.
Yes.
That adds value to the mentorship experience. So for me, it's a highly effective thing. One of the things that Prof. Delia North mentioned this morning, because you were talking about teaching, was that most of us, we could just trace back our motivation to pursue something to one particular teacher. There's this one defining person that inspired you or just gave you that little nudge to push you in the right direction. And sometimes that's all we need, that mentor, that cheerleader. Yeah.
Amazing. This is very true. Any other reflections?
Well, yeah. So this one comment here is very interesting in terms of discuss and engage with mathematical exploration early on at school already. So it's interesting that while I was, just for context, I was funded for my PhD by the CoE-MaSS, and they sent out emails at one point every year saying, okay, you guys need to do something in terms of community engagement, something of this form. And one of the options that they mentioned there in this email was you can go to your old high school and give a presentation there.
Yeah.
And this was, I found this idea very, very attractive. I actually went so far to send my old high school an email, but then that's when COVID happened. So this unfortunately never happened, but this is still something that I definitely want to do at one point, because I can imagine if you, just to touch with what Cerene has also said, I mean, yes, having a mentor would be fantastic, but I mean, if you were to create a high quality presentation that you can go give at your school and engage with them on a particular topic. If you choose the topic well, there's a lot of particular basically research level mathematics that you can explain to a high school student. I mean, you can talk about the Collat's conjecture, you can talk about, there's some problems in combinatorial number theory that you can explain to someone in grade 5, basically. So this, if you did a little bit of work there, this would certainly, I think this would have a very, very positive impact in showing kids at high school level that mathematics isn't just this sort of drudgery exercise where you now have to know your times tables and need to understand trigonometry and all of these things that some students, including myself, didn't necessarily find interesting at the time. To show them that there's more to it than just these sorts of things that we're teaching to you now.
Sure. Brilliant. Thanks.
Can I comment? I fully agree with what you said, Walt. And this is truly the essence of the Future Mathematicians program,
Okay.
where the aim is to do exactly what you had just said, whether it's through going and delivering a presentation or identifying activities that could help stimulate collaboration in a classroom. So I guess we should get chatting afterwards.
I love it. Networking happening already. Great. Colleagues, I would love for us to continue. I would, but we are standing between this lovely conversation and lunch that I'm sure the people at the back can smell already. Sorry? Do we still have time? Is that what you're saying? Lots of time. I've got lots of questions, so I can continue. So thank you. Yes. I've got lots of questions and lots of opportunities for questions. Thanks, Prof. Yeah, so maybe to wrap up this discussion, then we can open to the audience. I mean, there's a lot of improvement that needs to be done, and we understand that we are operating in a country that has limited resources. I think our colleague from the DSI mentioned just the level to which we got to be able to be creative in the way that we are sort of developing these entities and the way that we want to grow our impact. Can you think of other sort of more creative ways that are low cost but high impact that could allow us to actually be more visible as maths and statistical sciences? We had social media that was mentioned. I'd love to see some maths and statistical sciences questions going up on TikTok. That'll be interesting. I know I'm joking. I don't know if it'll work, but I'm just saying. But there's ways of creating visibility that is low cost but high impact. Can you just think through that? Or perhaps you can ask the audience. Can we do that? Are there any ideas from the audience? Low cost, high impact mechanisms for making our maths and statistical sciences famous in this country. Have you ever seen academics without a thing to say? This is amazing.
You can pass the mic. Yeah.
Thank you so much.
Hi everyone, I'm Delia North. I'm from the University of KwaZulu-Natal in South Africa. I'm a statistician. And what I have found to be a good way of creating role models is to challenge the honours students in the discipline, because by honours level they've chosen their area of interest, to go back to their school and to give a talk to kids at their school, because university holidays don't coincide perfectly with school holidays. Because what I've found is that no matter what area you come from, what particular geographical area in South Africa, for a learner in grade 10, 11 or 12, to see someone that comes from the same school gives them hope. I can go there and give a talk. It will not be as impactful as if they see someone that came from that area that has chosen a particular area of study, and they maybe should talk about what their experiences are, what their hopes are, and how they got to where they are. But by fourth year, it's a really good thing to do, and they have to come back with a photograph to show me that they did that talk, and maybe there's a little reward for them for having done so. But I think that's low cost and big impact. Let them go and talk about what they chose, what their experiences are, and what their hopes are for the future.
Brilliant. Thank you so much. We've got a hand right here in front.
Yeah. Hi. I'm looking at the comment there about let children embrace mathematics outside the context of competition.
Yes.
And that's sort of the type of thing that the Future Mathematicians program is trying to do, which is excellent. But I do want to add to that, because you asked about cost effective, and it is well researched that the most cost effective way of reaching the largest number of people, and I'm talking now specifically about learners at school, to expose them to mathematics beyond the school curriculum, is through competitions and problem-solving type activities. So, for example, the national competitions for primary school and for high school reach in the order of more than 80,000 learners at each level annually. And there are other competitions and that also reach many learners. And the value of that is that it's really going beyond the school curriculum, and the kind of interesting questions that are asked are really exposing them to mathematical, logical type thinking.
Yeah.
Not just with the kind of formulaic things that they're taught at school. So the issue of competition, that's very true, that you will find many of the people in mathematical sciences and being influential in the country credit mathematics competitions like the Mathematical Olympiad as the thing that really got them interested in mathematics. And the prime example is Mark Shuttleworth. He's the most well known. But there are many others that are now actuaries and whatever that really say this played a big role in making them choose mathematical type of mathematical future,
Sure.
Which just learning it at school level would not have done. But to go beyond competition, because not everybody, competition doesn't appeal to everybody, and competitions can be challenging and then scare off certain people. That's very true. And so for an example of what the Maths Foundation is trying for the first time this year is we are using the questions of an international competition known as the Kangaroo, which
Yeah.
some of you know, to apply it in a completely different context following the the National Maths Olympiad and Challenge at the primary school, to make it open from, so the first rounds have just been written, and now it's whoever makes it to the second round, that's a small group compared to the whole cohort that wrote the competitions. But we've taken the kangaroo questions, which already are designed and we have access to, and writing, so it's not going to be a competition, it's basically making them available, the different levels for each grade group. We've changed some of the questions to make them more relevant to South African learners. And this will be available to teachers from 22 of April until the end of August, to use in their classrooms sort of as an exercise or however they want to, and just literally expose their learners to this kind of interesting problem-solving problem, and it's slightly easier. Yeah. So that you get mass participation and they don't have to enter, there's no fees, no nothing, and we want to do more of that. I think that is a very good way of reaching learners and showing them what mathematics can be and what it's all about. And you can reach many, many learners through the network that we already have, not just those regarded as talented in mathematics.
That's it, right? I mean, that has been the challenge, is that a lot of this has been just reaching those that are already segmented and associated with some level of intellect or potential, and not really looking at potential in the broader sense, especially in our context where inequality is such a big problem. So thank you for that comment. Prof. Zurab, I think, oh, sorry. Can we have you first and then yourself?
Yes, so my name is Vicky from AIMS Rwanda. So actually, based on how we can foster or maybe make sure that we have we can impact more the youths. I just have a comment on what one of the panelists was saying. She was like, okay, maybe we should identify a platform where those young people can discuss among them. So what I wanted to mention, because I had a discussion with some young people working on STEM field in UK, Indonesia, and in 2 universities in Africa. What I got from them is actually when we're talking about this mentorship aspects, mostly the young people are having this kind of mentors from another generation. And mostly the mentors are not, in the same generation. As someone was saying that we should make sure that the student goes back, like the same age group of student goes back to their school in order to, to foster more awareness, and for their younger, seeing them from the same age, it can make more impact. And I think the kind of this role models aspect that we can work more on is to bring more role models in the same generation. And this can make more impact than, it's good that we are learning from the elders, the young people are learning from the elders and so on. But when the gap of the generation is too big, it's difficult for them, to be able to see themselves, to see how they can, adapt, based on the environment where they are, and then they with the technology and so on. Our elders doesn't have the technologies when they were doing the STEM field and so on. Today we do have technology, we do have many things. So how are they adjust in this kind of environment? So I think this is something that we also have to be aware of, how to make sure that in the mentorship system we also bridge the gap of generation.
Thank you very much. Yeah. Useful comment. Prof. Zura?
So this is a question for the panelists. Well, actually, I was the one who made that comment about competition, but at the same time, it is very important, as was mentioned yesterday in the last talk, it is very important for human beings to be told that what they're doing is good and that they're doing it very well. And competitions is certainly one way of achieving that. So those who win these competitions, for them these competitions are extremely beneficial. And in light of that, I would like to ask the following question to the younger mathematicians. There are a lot of international prizes for achievements in various fields, including mathematics. For example, there is the Fields Medal. So I would like to hear your views about what would it take for South African, let's begin with one. Well, we already have one, but he's not working in South Africa currently. For a South African mathematician to get a Fields Medal, what do you think it takes to achieve that?
I thought I had the hardest question for you, but clearly not. Did you guys get the question? Yeah? Okay, Cerene?
It's a difficult one to answer. But my views is that you have to have a very novel idea that is going to bring about impact in the mathematics community and broader fields. Because if you look back at what work was already awarded, the Fields Medal, the Arbel Prize, Nivelina, etc., that's the type of work that was done, and it seems that that's what the IMU, etc., is looking for. So it has to be, I guess, novel research, and Prof. Jordan has a hand.
Sure, noted.
I can maybe just rephrase the question to make it broader, to make it easier for you to answer. So just to make the question a little bit broader, because it's a very good question, but let's not just look at the Fields Medal. I was very privileged to be an observer at the IMU executive meeting that they held at Ames in February 2020. And the conversation there was about the next speakers, plenary speakers at the International Congress of Mathematicians. There never are people from Africa, or hardly ever. And so they asked, Prof. Louisa was also there because he was vice president at the time. We asked the questions, what will it take for you to ask people from our continent to speak there? And the big issues were they didn't know about what, so it's connectivity, exposure, international, because we said, what about this A-rated person? What about that A-rated person? And they'd Google and say, never heard of him. Things like that. So how do we get our top researchers more international exposure, I think should be the question, so that they are recognized when representatives from different continents and countries are invited to speak at these international forums.
May I modify the question further, Kirsten? I think your question is more for more senior mathematicians. My question was for junior mathematicians, and I wanted to hear from them what their thinking is, what it takes, because you are now at the point where potentially you could get a Fields Medal, and it's anyone below the age of 40 can. So what do you think it takes to arrive to a place where you will get a significant international recognition? It could be Fields Medal or another, for instance, an invitation to the IMU Congress, as Kirsten pointed out. What do you think it takes to get there?
I'll comment again.
Can I have Walt?
Well, for me, I only have 10 years left for my Fields Medal, so I better get started. So, yeah, well, to be completely honest, I think you have to also acknowledge the fact that you really have to be at the right place at the right time. Sure. This is not just a startup project, so you have to, yeah. Probably your institution already needs to be completely entrenched in the right field, and then you need to get in there. Hopefully you can make some waves, but yeah, it's certainly not something that you on your own by sheer force of will can just do. There's other factors beyond that you obviously need to consider. So
Thanks,
perhaps that's a bit of a pessimistic answer, but
no, but I think the issue of support or enabling environment is a key issue. So thank you for bringing that up. Can I have yourself, Cerene, and then?
So from my experience and what I learned at the Heidelberg Laureate Forum is that the laureates themselves have had these ideas for a very long time. And they spent multiple years thinking about these concepts. And then coming back to what you're saying about being in the right place at having the right time, is that they then made initiatives to seek out collaborators who could help them formulate their ideas and put it into the right format, and they went to specific research centers that focused on that area that they were working in. So it's a collection of many things that needs to take place. The idea, finding the right people, going to the right place, and persistence.
Tsinjo?
For me, I think like beside networking and exposure, we should start with high school level, because if we can train a strong mathematician at that level, then there is a chance that we could get something like, yeah.
Sure. So being able to find the
Yes.
talented young people at that
Exactly.
level, and then from there, what should we do with them?
They should be trained. Yeah. Because I think there is also the difference between systems, because if we take an example of like here in maybe in Africa in general, like PhD students don't follow like courses. You just go straight to like a research. But like in Europe, you have to do like other things besides your research, and that also like helps a lot, I think.
It's interesting. Thanks. Heather, do you have any thoughts?
My field is applied mathematics, so I think that for someone in my field to get a Fields medal, it's necessary that after doing that research, they try to engage or collaborate with the industry so that the results have an application, and after seeing that the results work, they can get the medal.
Sure. Brilliant. You guys took that very well. Congratulations. Any other questions, comments? Yes.
Thank you very much for this wonderful presentation. And when they started the discussion, they showcased how science communication through CoE-MaSS is helping them with the career progression, research insights, right? So 4 of them, my assumption is that they never had science communication before. Am I right? Did you have science communication before? Okay, in your university training? No, okay. So what I sense is that this is not just for them, but it's for the entire country. And it's not just for South Africa, it's the entire continent, the lack of training on science communication within our academic system, right? So my question is not for you, but just posing on the leadership of CoE-MaSS universities. We talk about science communication being important, and we are sitting with policymakers. Nowadays, they really want us to communicate, right? It's there in the proposal. They ask you, tell us what you want to do research, but then tell us how you will engage the public. So already we can see the policy there. The question is, how do we train these youngsters, young scientists, early in their careers, BSc level, to be able to communicate their mathematics? The intervention that we have now is when they're at this level. And if we look at them, they're representing minority from their university. What about the pool of the students who are sitting there? How are they going to get this science communication? So this is for us all to think about it, on how we should equip these students while they're still in their graduate level. Thank you.
Thank you very much, a valid point. And maybe if I could add, you could see the results, especially maybe from a confidence building level, of them having received science communication through the interventions of CoE-MaSS. And you spoke a little bit about what you've been exposed to already. Just from the way that you've been able to hold this conversation and be able to speak around your research areas, and with the level of confidence and clarity that you have, which is something that is very, very difficult to do. So I would just want to congratulate you on doing well on that. But yes, the point, we need this at much earlier levels in your career as you're developing in the academy, because the value of it, so if you look at return on investment, the value of it, well, we've sort of heard the examples, so it speaks for itself. Any other questions or comments, or are we all desperately looking for lunchtime? Did the former Vice-Chancellor of Wits just scream, yep? Did that happen? Diane, last point. You do.
Sorry, this might have come up. I had to leave the room for a few minutes. It's a question for the panel. In terms of science communication, you've all mentioned you've taken part in some form of it or another. What's the most challenging thing that you faced, or the thing that you felt negative about in terms of taking part in science communication? What was the thing that you did not enjoy about it the most, or that you found, one or the other, that you found the most challenging, or that you just really didn't like about it?
I think like asking a pure mathematician to find an application. Yeah, that's one of it.
So you mean actually translating something that's quite theoretical?
Yeah, and we don't know even what is the application. Yeah. And it is always requested from the founder.
Well, you get used to it eventually, but if you have to speak in front of a room of experts for the first time as a master student or an honors student, that's rough. But yeah, as I said earlier, it's exposure therapy at the end of the day. And you eventually realize that within the very narrow band of what you are talking about, that in your talk, it's very likely, besides if you remove your supervisor, you are basically one of the people that knows the most about that particular thing that's on the screen. So, yeah.
Well, I think I can just add to what he said. Sometimes, especially if you're new, it's quite intimidating. When you're presenting, the first minutes you'll be shaking, but with time you get better.
For me, I think a challenge when it came to like 3-minute elevator pitch, it's about taking the time to break down the complex ideas into a translatable language that anybody would be able to understand. And so that for me was the most challenging thing, taking what I do and reformulating it into something that the layman would understand. But I didn't think that that was a hard thing to do. It just needed time, and I enjoyed the challenge. Yeah.
Thank you.
Thank you very much to the audience for those lovely questions, and thank you to the panel for engaging with the audience very confidently. So we are now at the end, so yes, we can give them a round of applause. And just to encourage you, if you have any more questions for the panel, please go ahead and ask them as we are having our lunch. I'm sure they'll be happy to engage with you. And that's a wrap for our session. Thank you.